Assalamu alaikum guys. In this short video lecture I will guide you for steel reinforcement details in the construction of this floor beam. They did some common mistakes, so let me point out those mistakes in front of you in this practical video. This is RCC floor beam. Size is 12 by 18 inches with concrete cover. Length of this floor beam is 24 feet. Here in tension zone, which is bottom, we have 4 steel rods, dia is 16 mm. In compression zone, which is upper portion of this beam, we have 3 steel rods, dia is 16 mm. So what is the big mistake? Guys, you can see clearly, the length of this floor beam is 24 feet, but they didn't provide any crank bar or extra steel rods in the construction of this floor beam, where at the distance of L by 4, we have negative bending moment. To resist negative bending moment, they didn't do any structural drawing in this floor beam. Unfortunately, they placed the lapping in bottom portion of this plinth beam, floor beam, which is at the distance of L by 4. So this is one of the big mistake. They didn't do any crank bar, any extra steel rods to resist negative bending moment, in the length of this floor beam is 24 feet. You can see clearly. On the other side, the beam length is 22 feet. So 22 by 24 feet. Steel reinforcement design is same, but they didn't follow any steel structural drawing. So therefore, this is not the proper design of steel reinforcement in the construction of this floor beam. Next guys, you can see the stirrups. Spacing is about 8 inches. You can see hooks are bent on 90 degree. So this is the second big mistake. It should be provided on 135 degree, and the spacing should be closely at the distance of L by 4, where we have negative bending moment. After L by 4, they can increase the spacing of stirrups. Guys, you can see they didn't provide any extra steel rods or side bars, which are important because the depth is 18 inches. Guys, you can see at the end of the beam, they didn't provide any development length. Also, they have cantilever slab or chajja, which length is about 4 feet. Side bars are very important to provide in this floor beam construction. That's why, because they don't have more technical terms in this beam, but you can see they provided lapping in the junction between beam and column at this place, but at the end of the beam they didn't provide the development length, which is very helpful to make a good bond between steel and concrete. You can see this is the other floor beam construction. Size is same, 12 by 18 inches. You can see at the distance of L by 4, at this place they provided extra steel rods or side bars, which length is about 6 feet, because we have the length of this floor beam 24 feet. Stirrup spacing is about 8 inches. You can see the hooks. Hooks should be provided alternately. Don't place at the same direction. This is column. Size is 15 by 15 inches with concrete cover. It will be 18 by 18 inches. They used here 8 steel rods. Dia is 16 mm. They will used here M20 grade concrete. This is bottom portion. We have 4 steel rods. They used 60 grade steel rods. Dia is 16 mm. This is tension zone. And this is upper portion, which is compression zone. We have 3 steel rods. Dia is 16 mm, and the middle bar dia is 12 mm. You can see the width is 12 inches. Depth is 18 inches with concrete cover. The ring size is 9 by 15 inches. You can see we have 2 side bars at the distance of L by 4. From start to L by 4, this is the total length, which is about 24 feet, but at the distance of L by 4, we have extra steel rods. on both directions. Development length is very important to provide at the end of the beam. Crank bar is very important to resist the negative bending moment. Spacing of stirrups should be closely according to steel structural drawing at the distance of L by 4 from 150 to 200 mm or from 6 to 7 inches. Next, you can see they placed here 2 extra steel rods instead of 4 steel rods at the bottom. The middle bars should be cranked or bent up at the angle of 45 to 60 degree, but unfortunately they don't know about what is crank bar, what is bent up bar. So therefore they placed the normal design of steel reinforcement for this floor beam because they don't have the structural drawing. But this is commercial building, not residential building. So therefore I am telling you, if you are working on construction site or if you want to build your house or commercial building, so you should hire the structural engineer, also the site supervisor to guide you during construction of steel reinforcement. Guys, you can see on the other side this is cantilever beam. Design is same. This is simply supported beam. On the other side there is cantilever beam, but the design is same. Cantilever beam and simply supported beam steel reinforcement should be changed from each other. This is why, because in cantilever beam we don't have any support at the end of the beam. So this is free end beam. Therefore the design should be changed and the bottom portion steel reinforcement should be the opposite of compression zone. But unfortunately they did the same design of this. You can see clearly. So they did more mistakes. We have a lot of technical terms, so we should know about those terms if we are working on construction site. Actually this is commercial building which is up to 4-story building. Okay, you can see the stirrups. Dia of stirrup is 8 mm. Hooks are placed at the same direction and hooks are bent on 90 degree. It should be provided alternately, as you can see. So now this is at the same direction, but here sometimes they did at the same direction, sometimes they did alternately, but it should be provided alternately. Don't place at the same direction. You can see this is the junction between beam and column, and there is free end. At the free end we should provide development length, which length should not be less than about 6 inches. Hope this short video can help you. Thanks for watching. See you in next video. Goodbye.